All right. Hello, we are here to do a video walkthrough of practice quiz number 2 for LT11, polynomials and complex numbers. Let's start with golden standard 11.1. Students can simplify expressions with I. So what does this look like? 2i to the 16th power times 3i to the 21st. Well, let's remember our exponent rules. 2 times 3 is 6. Now, I to the 16th times I to the 21st. When we multiply things like this, we add the exponent. So I've got 6i to the 37th power. Okay, I don't want to deal with the 37th power. I can simplify that. So let's think about 37. How many times does 4 go into 37? 37 divided by 4, turns out that goes in 9 times with 1 left over. So essentially, I to the 37th is the same as I to the 4th times 9 of them, times I to the 1st. Well, the key thing here to realize is that this I to the 4th is just 1. So that's like 1 to the 9th times I to the 1st, which is just 1. So all that simplifies down to is just I. So our final answer would be 6I. All right, for the second one, 5 to the square root of negative 48. The way I like to do these is to break up the square root. What's the largest perfect square that goes into 48? Again, perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so forth. Well, the biggest one that goes into 48 would be 16. All right, so that means I have the square root of 16 times the square root of 3, because 16 times 3 is 48. And then I have to account for the square root of negative 1 because it's negative. Now, simplify it further. 5 times the square root of 16 is 4. Square root of 3 is the square root of 3. Can't simplify that. And the square root of negative 1 is I. Pull the pieces together that are outside the square root. 5 times 4 is 20. 20 times I is 20i times the square root of 3. Okay, that's golden standard 11.1. Moving on now to, just adjust this a little bit. Moving on to standard 11.2, completing operations with imaginary numbers. These are all about putting real with real, imaginary with imaginary, and remembering, key thing here, that I squared equals negative 1. Remember that. So let's do this first one. First step, let's distribute. Negative 4 times 1 is negative 4. Negative 4 times negative I is plus 4i. Negative times a negative. Negative 3 times 5 is negative 15. Negative 3 times 3i is minus 9i. Now what we got to do here, real goes with real. So negative 4 minus 15 becomes negative 19. Plus 4i minus 9i becomes minus 5i. All right, for this one over here, simplify. We're multiplying 7 plus 2i times 7 minus 2i. When we're multiplying binomials, go back to our old friend, the area model. 7 plus 2i, 7 minus 2i. 7 times 7 is 49. 7 times 2i is 14i. 7 times negative 2i is negative 14i. Negative 2i times 2i, negative 2 times 2 is negative 4. I times I is I squared. So what happens here? I see 14i minus 14i. So those cancel. So I'm left with this, 49 minus 4i squared. Now remember, I squared equals negative 1. So that means we get 49 minus 4 times negative 1, which is 49. Negative 4 times negative 1 plus 4. So it turns out those two multiply to 53. And for the last one, simplify 1 over 6 minus 3i. Now we hate having imaginary numbers in the denominator. Denominators are the key to fractions. So what do we want to do? We want to eliminate the I. How do we get rid of the i's? We multiply by its conjugate. Okay, multiply by the conjugate. Multiply by conjugate. Remember conjugates, if one is a minus bi, then the conjugate is a plus bi. Okay, change that sign. So the conjugate of 6 minus 3i is 6 plus 3i. Now we have to multiply by 1, so we don't change the expression at all. Right. So we multiply by 6 plus 3i over 6 plus 3i. Well, that times 1 is just 6 plus 3i. And now I get this on the bottom. 6 minus 3i times 6 plus 3i. Well, that's kind of like what we just did right here. Let's make an area model. Can use that piece right there as our area model. So we got 6 minus 3i and 6 plus 3i. 6 times 6 is 36. Negative 18i. Negative 3 times 6. 3 times 6 is 18i. 3 times negative 3 is negative 9i squared. What does that simplify to? 36. Those cancel. Minus 9i squared. I squared is negative 1. Negative 9 times I. Negative times negative 1, becomes positive. So the bottom of our fraction becomes, sorry, I'll put a little down arrow right here, 6 plus 3i over 6 minus 3i times 6 plus 3i became 45 after we multiplied them together and simplified. This is where we want to finish, right there. All right. So that's the front side, standards 11.1, 11.2. Let's move on. For 11.3, identifying characteristics of a polynomial given an equation or graph. So for the equation, lowest possible degree, this is in factored form. So we got to think about if everything was multiplied out, what would be the highest degree, highest power of a single term? Well, I see x plus 1 cubed. So the highest thing out here is going to be an x cubed and an x squared. Cubed times squared is going to give us x to the 5th. All right, so if we multiply this all out, we would end up with an x to the 5th. That means there are 5 total roots. Well, how many real ones are there? How many complex ones are there? For this, we have to look at each factor. So this one, x plus 1 cubed. Well, what would make that equal to 0? Could we see that in a graph? Could we see that in a graph? Could we solve that? Yeah. That just means x needs to be negative 1. There's a triple root at negative 1. And how many roots are there? 3. It's a triple root. So there are 3 real roots. Now, how do I know that these ones aren't real? Well, think about this equation. X plus squared plus 5 equals 0. If I were to solve this, I would subtract 5 from both sides to get x squared equals negative 5. X squared equals negative 5. Square root both sides. I'm taking the square root of a negative. That means I'm going to have complex numbers. Now, complex roots always come in pairs. Always in pairs. 2, 4, 6, 8. You never have an odd number of complex roots. Also, the total number of roots must be the number of real roots plus the number of complex roots. So in both cases, the answer must be 2, because in this case, it's the square root of 5 plus or minus I square root of 5. All right, for the graph, what do we see? Lowest possible degree. Well, it's odd. How many pieces do we see? Like how many parts of the graph? 1, 2, 3, 4, 5. Imagine this swoop through the real axis, the x-intercept. Imagine they were all real. We'd be like, okay, this is a 5th degree. There could be 5 separate roots. So 5th degree, 5 roots. Now, how many real roots are there? Those are the x-intercepts. I see 1, 2, 3. So there are 3 real roots. In that case, how many complex roots are there? 5 minus 3 means we're left with 2. Again, an even number. This right here, where it turns right here, but doesn't cross the x-axis, this is where we are seeing behavior influenced by our complex roots. This isn't the complex root. That's not the complex root right there. But this behavior is influenced by the fact it has 2 complex roots. All right, 11.3. Let's move on to 11.4. Our question here, what is the equation in standard form? We want to ultimately write it in standard form of a cubic polynomial with roots of x equals 5 minus 7i and x equals negative 5. Assume a equals 1. Well, my first step from this would be to say, okay, I have a complex root right here. I can't have just one complex root. They always come in pairs. The pair is the conjugate. So if I know I have x equals 5 minus 7i, what other root do I know I have? X equals 5 plus 7i. So those must be my three roots: 5 minus 7i, 5 plus 7i, the conjugates, and a real root at x equals negative 5. So what does this look like in factored form? Basically, I have to work backwards. Well, let's start here. If I know that x equals negative 5, that means my factored form is going to be x plus 5, because it would make it 0. If I put a negative 5 in here, this would be 0. So my second root, 5 minus 7i, how would I write that in factored form? Well, that would be like x minus 5 minus 7i. Because if I took this and subtracted it away, I would have the opposite. Okay, I'm just subtracting it away. My last root, x equals 5 plus 7i. It's kind of the same thing. Start with x, subtract, the same thing. I'm just taking it away. Now, all that is our factored form. Now, let's simplify this a little bit. X plus 5, distribute the negative, minus 5, minus negative 7i becomes plus 7i. And you see here, if I put a 5 minus 7i here, 5 minus 5, negative 7i, plus 7i, it would all cancel out. And then here, distribute the negative, minus 5, minus 7i. If I want to find it in standard form, what do I have to do? I have to multiply it all out. So I'm going to multiply these two first, my two trinomials here. When you're multiplying trinomials, it gets really hard to do by drawing rainbows. Area model will be your friend, trust me. So on one side, I've got x minus 5 plus 7i. Other side, I've got x minus 5 minus 7i. All right, fill in the boxes. X times x squared. X times negative 5, negative 5x. 7i times x is 7ix. Negative 5 times x, negative 5x. Negative 5 times negative 5 is 25. Negative 5 times 7i is negative 35i. Negative 7i times x is negative 7ix. Negative 7i times negative 5 is 35i. Negative 7i, positive 7i, negative 49i squared. Okay, you may notice there's a bunch of stuff in here that are opposites, that is going to cancel. What cancels? 7ix, 7ix. What else cancels? Negative 35i, positive 35i. So what are we left with? Don't forget about the x plus 5. It's still hanging out there. Well, I've got x squared minus 5x minus 5x plus 25 minus 49i squared. We can simplify this. Nothing goes with the x squared. Minus 5x is minus 10x plus 25. Remember, I squared is negative 1. So this is like negative 49i squared. Negative 49i squared is like negative 49 times negative 1, which becomes positive 49. So this becomes plus 49. Let's simplify a little bit further. X squared minus 10x. 25 plus 49 becomes 74. I'm not done yet. I want it all the way, not factored at all, fully in standard form, which means I need to multiply this binomial times this trinomial. Let's do it. So here, I like to make my area models really big. Why crunch it? 10x plus 74 times x plus 5. X times x squared is x cubed. X times negative 10x is negative 10x squared. X times 74 is 74x. 5 times x squared is 5x squared. 5 times negative 10x is negative 5x. Sorry, negative 50x. 5 times 74 is 370. Okay, so now I have my full standard form. X cubed minus 10x squared plus 5x squared is negative 5x squared. 74x minus 50x is plus 24x plus 370. That is my final answer. So what is my answer in factored form? This is factored form right here. Actually, this one, sorry. This one right here is my answer in factored form. Okay, that's factored. X plus 5, x minus 5 plus 7i, x minus 5 minus 7i. My answer in standard form is this one after I'd multiplied everything together. X cubed minus 5x squared plus 24x plus 370. That's my final answer. Hope this was helpful. Check Canvas for more resources to help you review and prepare. Good luck.